Hi to everyone. In the last session, we had already seen about ionic bond and the illustration for ionic bond and the characteristic of ionic compounds. Here we are going to see about covalent bond and the formation of covalent bond and the illustration for covalent bond and the characteristic of covalent compounds. So, before that we should know what is unpaired electron and what is valence electron. As I already told you, valence electron is nothing but an electron that is present in the outermost shell of an atom. So last shell consists of some electron. That electron is called as valence shell electron. So it may differ from atom to atom. Let's say what is meant by unpaired electron. Unpaired electron is nothing but an electron that is unpaired. That is, it exists in a single state. It does not come in any other atom. That is, it does not occur as a paired one. It is an unpaired. It exists in a single electron. That electron is called as unpaired electron. So covalent bond is mainly based on the concept of these unpaired electrons. So let us see about the covalent bond. According to a Lewis concept, when two atoms form a covalent bond between them, each of the atom attains stable electronic configuration of the nearest noble gases. So consider two atom. The two atom consist of unpaired electrons in which the covalent bond is formed between them because of the sharing of the unpaired electrons in order to attain the stable electronic configuration of the nearest noble gas. I already told you what is noble gases. The element that is present in the 18th group of a periodic table, that is helium, neon, argon, krypton, xenon, radon. So these two atoms form a covalent bond by sharing the unpaired electrons within them to attain the nearest electronic configuration of a noble gas. Since the covalent bond is formed because of the sharing of electrons which become common to both the atoms. So this shared electron is common to both the atom. So thus a bond is formed. That bond is called as atomic bond. The other name for covalent bond. Okay, let us move on to the formation of covalent bond. So let us consider a two atom A and B. So A atom has a 1 valence electron and atom B has a 7 valence electron. I already told you what is valence electron. Valence electron is nothing but an electron present in the outermost shell of an atom. So one atom consists of, that is atom A consists of a valence electron 1 and atom B consists of a valence electron 7. So as these atoms approach nearer to each other, they are approaching nearer to each other, each atom contributes one electron. So the atom A consists of one electron, that is the first shell itself consists of one electron, and atom B consists of 7 electron, that is the first shell consists of 2 electrons, and second shell consists of 4 electron, and the third shell consists of 1 electron, that is a 7 electron. So these electron, that is the last electron that is present in both the A and B, combine with each other and contributing 1 electron, and the resulting electron pair fills the outer shell of both their atoms. Atom A share 1 electron and atom B share 1 electron. So thus the bond is formed. So totally 2 electrons, pair electrons are common for these two atoms A and B. Thus both atoms acquire a completely filled valence shell electronic configuration which leads to stability. So that's a bond is formed. Covalent bond is formed. Both their needs are fulfilled in order to attain the nearest electronic configuration of noble gases. Okay. So let us move on to the illustration 1, that is a formation of hydrogen molecule. We already know that the formula for hydrogen molecule is H2, in which it consists of a 2 hydrogen atom hydrogen is a diatomic molecule, so it consists of a 2 hydrogen atom. The hydrogen molecule is formed by 2 hydrogen atoms. While forming the molecule, both hydrogen atoms contribute 1 electron each to the shared pair. So, refer the periodic table. The atomic number of a hydrogen is 1. That is, the electron present in the hydrogen atom is 1. So, each hydrogen atom has a 1 electron in it. So, it needs one more electron to attain the electronic configuration of a helium. That is 2. Helium is an inert gases. Its electronic configuration is 2. So, each hydrogen atom, it consists of 1 electron in it, and it needs one more electron to attain the stable electronic configuration of a inert gases helium, which is nearer to it. So, it contributes 1 electron each to the shared pair, and both atoms acquire stable and completely filled electronic configuration by sharing the electrons. So, both the hydrogen atoms shared 1 electron to each, and listen to the diagram. After the formation of hydrogen molecules, the shared pair of electrons picture is given. So, this 2 electron is shared by both the hydrogen atoms. That is, hydrogen atom 1 contains 2 electrons in it, and hydrogen atom 2 contains 2 electrons in it. So, both the 2 hydrogen atoms fulfilled the octet rule. That is the nearest electronic configuration helium it attained. So, it attained the nearest electronic configuration of a helium, that is 2. So, thus the bond in the hydrogen is formed, hydrogen molecule is formed. That bond is a covalent bond. It is formed by the shared pair of electrons. Okay, hope you understand this. Let us move on to illustration 2. That is a formation of a chlorine molecule. As I already told you, the hydrogen is a diatomic molecule. In the same way, chlorine is also a diatomic molecule in which it contains 2 chlorine atoms. We already know that electronic configuration of chlorine is 2, 8, 7. One atom of chlorine contains the electronic configuration of 2, 8, 7. So, it consists of a 7 valence electron in its outermost shell. 7 valence electron in its outermost shell. And these 2 atoms achieve stable, completely filled electronic configuration by sharing a pair of electrons. So, listen to the diagram. The last shell consists of 7 electrons, in which a 1 electron is shared by both the atoms. That is, chlorine 1, first atom of chlorine, share 1 atom with the second atom of a chlorine. In the same way, second atom of a chlorine share 1 electron with the first atom of a chlorine. Thus, a shared pair of electron is formed. Listen to the figure. In the diagram, it is clearly represented a shared pair of electrons. That is, 2 electrons common to both the atoms of chlorine. Thus, the bond is formed by the sharing of electrons of both the atoms. So, now, both of the atoms, that is, atom 1 of chlorine and atom 2 of chlorine, contains 8 electrons in its outermost shell. That is the nearest noble gas argon, in which the 2, 8, 8. That it attains the octet rule. Thus, the bond is formed between the 2 chlorine atoms. So, by sharing the electrons of chlorine atom 1 and chlorine atom 2, it attains the nearest inert gas configuration of argon. That is 2, 8, 8. Thus, the bond is formed. That bond is called as covalent bond. Okay. Hope you understand this. So, third illustration is the formation of a methane molecule. So, you already know the formula for methane is CH4, in which it contains 1 carbon atom and 4 hydrogen atom. We already know that a carbon atom has a 4 valence electron. That is, the outermost shell consists of 4 electrons. And the atomic number of a carbon is 6. That it contains totally 6 electrons, in which the first shell consists of 2 electrons and second shell consists of 4 electrons. So, the valence electron, that is, outermost shell consists of 4 electrons in it. These 4 electrons are shared with the 4 atoms of hydrogen to achieve a stable electron configuration by sharing a pair of electrons. Hydrogen has a 1 electron in it. 1 atom of hydrogen consists of 1 electron in it. So, 4 hydrogen atoms consist of 4 electrons, each having 1. So, these 4 hydrogen atoms, electrons will be shared with the outermost valence shell electron of a carbon. So 4 in carbon atom. 4 hydrogen consists of 4 electrons. So 4 plus 4 is 8. So then the carbon atom, electronic configuration of a carbon atom will become 2, 8, which is the nearest electronic configuration of a neon, 2, 8. In the same way, by sharing the electrons of hydrogen with the carbon, each hydrogen attains the nearest electronic configuration of a helium, that is 2. So thus a bond is formed between the C, that is carbon, and H, hydrogen. So CH4 is formed. Here the bond is formed by the sharing of electrons. By sharing the electrons of carbon with hydrogen, carbon attains the nearest electronic configuration of a neon, that is 2, 8, and hydrogen attains the nearest electronic configuration of a helium, that is 2. Thus the bond is formed, and that bond is called as a covalent bond. Okay, let us move on to illustration 4, a formation of oxygen. Oxygen is also a diatomic molecule. We can write the oxygen molecule as O2, in which it contains the 2 oxygen atoms. So electronic configuration of oxygen is 2, 6, in which it consists of a valence electron of 6, because the first shell consists of 2 electrons and second shell consists of 6 electrons in it. So in order to attain the stable electronic configuration by sharing 2 pair of electrons, so oxygen needs 2 more electrons to attain the stable inert gas configuration of a neon, that is a 2, 8. Neon is the nearest inert gas configuration to oxygen, so it tends to attain the nearest electronic configuration of neon. So 2, 6 is the electronic configuration of oxygen. It needs 2 more electrons, that is 6 is in the valence electron of oxygen. It needs 2 more electrons to attain 8. So these 2 electrons will be shared with the other oxygen atom. So oxygen 1 atom share the 2 electrons with the oxygen 2 atom, and oxygen 2 atom share its 2 electrons with the oxygen 1 atom. So both the oxygen atom now contains 8 electrons in its outermost valence shell, so that it forms a bond. So in the diagram it is clearly given 2 shared electron pairs is there. So each oxygen atoms attained the electronic configuration of a nearest inert gas neon, that is 2, 8, by sharing 2 electrons. These 2 electrons is common to both the atoms, that it attains the 2 plus 6, that is 8. Same way another oxygen atom also it attains 2 plus 6, 8. So the bond, covalent bond, is formed in the same manner. Okay, hope you understand this. And last one is a illustration of nitrogen molecule. As I already told you, nitrogen is also a diatomic molecules in which it contains 2 nitrogen atom. So the electronic configuration of nitrogen is 2, 5, in which the first shell of nitrogen atom consists of 2 electrons and the second shell consists of 5 electrons. It needs 3 more electrons to fulfill the nearest inert gas configuration of a neon, that is 2, 8. It contains 2, 5. So by adding 3 electrons, that is 5 plus 3 is 8, it forms a triple bond. By sharing the 3 electrons, it forms a triple bond. Thus the sharing 3 electrons by both the atoms, the 3 electrons will be common for both the nitrogen atoms, thus it forms a triple bond between them. It's a covalent bond. So thus thereby it attains the nearest inert gases configuration of a 2, 8, that is a neon. So thus a bond is formed between the nitrogen atom. So nitrogen contains 2, 5. By sharing 3 electrons common to both the atoms, nitrogen 1 atom gives 3 electrons to nitrogen 2 atom. In the same way, nitrogen 2 atom gives 3 electrons to nitrogen 1 atom. By sharing these 3 electrons both, it attains the nearest inert gases configuration of neon, that is 2, 8, and triple bond is formed because 3 electrons are shared in it. So triple bond is formed between the nitrogen atom. Thus bond is called as covalent bond. Okay, hope you understand the illustrations. Next one is a characteristic of a covalent bond. So covalent bond, it contains physical state of covalent bond will be depending on force of attraction between the covalent bond. the bond may be a weaker or stronger. Thus, covalent compounds exist in gaseous, liquid and solid state. Thus, depending on the type of covalent bond, it may be a solid, it may be a liquid, it may be a gas. And the bond may be a weaker or stronger depending on the force of attraction between them. So, not all the covalent bonds are stronger and not all the covalent bonds will be weaker. It depends upon the force of attraction between them, and it exists in the covalent compounds exist in all the three states: solid, liquid, gases. It exists in all the three states. Example for gases is oxygen. So I already told you that oxygen molecule contains covalent bond in it. It is a gas. And water. Water is also a covalent compound and it's a liquid. The bond existing in a water is a covalent bond. So it is a liquid. And a solid example is diamond. So diamond, the bond existing in the diamond is covalent bond. It is a solid. So the covalent compounds may be a solid, liquid or gases. Okay. Next one is electrical conductivity. Thus, covalent compounds conduct electricity. So they do not conduct electricity. They are the bad conductors of electricity because they do not contain the charged particles. It does not contain ion. As I already told you, the ionic compounds conduct electricity in a liquid state because it contains some ions in it. Whereas it does not contain any ions in it. It does not contain any charged particles. It does not conduct electricity. It is a bad conductors of electricity. What about a melting point? So except a few covalent compounds, that is a diamond and a silicon carbide, they have relatively low melting points compared to ionic compounds. Covalent compounds have a low melting points. Most of the covalent compounds have a low melting points. It melts at a very low temperature when compared to ionic compounds. But diamond and silicon carbide are the two covalent compounds that have a high melting point. Okay. Next one is solubility. Covalent compounds are readily soluble in non-polar solvents like benzene, carbon tetrachloride, and they are insoluble in polar solvents like water. We'll discuss it in a 10th standard. That is a polar solvent and non-polar solvents. Most of the substances dissolves in water. They are polar solvents. Whereas some of the substances does not dissolve in water, they may dissolve in a non-polar solvents. That is, a solvent is a liquid which dissolves a solute. So some of the compounds dissolve only in non-polar solvents like a benzene, carbon tetrachloride, like that. So these covalent compounds are readily soluble in non-polar solvents only. It does not soluble in water. Yes, it is insoluble in water. Next one is hardness and brittleness. Covalent compounds are neither hard nor brittle, but they are soft and waxy. So they are neither hard nor brittle, but they are soft, very soft and waxy. Okay. Reaction of covalent compounds is a molecular reaction solution, and these reactions are very slow. The reaction taken by a covalent compounds. Covalent compounds undergoes a reaction at a very slow rate. Okay. So these are all the characteristics of a covalent compounds. Hope you understand this concept. We will see Fajon's rule and coordinate covalent bond in the next session. Thank you.